if we take, suppose, here we take a surface. This surface separates two media. Here we consider this is air. Right now I said the velocity of light in vacuum and air both are same, equal. So instead of considering vacuum, we can consider air. And here it is water. It is water. Now if a light ray enters from air into water, definitely the nature of medium changes, then the velocity changes. Due to change in velocity, the path changes. Or we say that refraction taken place. If the medium does not change, then the light must travel along this straight line. Here if we take, this is air, light enters obliquely, then it enters into another medium, suppose it is glass, and it deviates. On entering from one medium, definitely it changes, so we are showing the change in the path of light. So in both the cases, refraction takes place. In this, the light travels with the speed of light. The light travels with some speed. In vacuum, in air, it is at most, it is represented by c. It is represented by c. Now from this air, it enters into water. From air, it enters into glass. Here we take it is first medium, second medium. Now you see, the first medium in both are same, but the second medium is not same. Here it is water, it is glass. In this, its velocity changes. Here also the velocity changes, but the change in velocity on entering into water, on entering into glass are not same because their nature is different. That's why the change in the path of light, will also be different. That is, refraction of light is different. Here we take the velocity of light on entering into water, it becomes v. Let us take, this is w. This is velocity of light in glass. Now both the velocity will be different. Here it is entering from air into water, air into glass. Now we see, here if we take the ratio, then it is the ratio of velocity of light in vacuum to the velocity of light in water. And here if we take the ratio of velocity of light in vacuum to the velocity of light in glass, this ratio will also be different because the nature of medium, second medium, it is different. But if we take the third case, here this is air and this is water. This is water. But in this case, we take the light ray in air which strike the surface at some angle. Here also it strikes some angle. And in this case also it deviates from its path. Here also refraction takes place, here also refraction takes place. In both the cases refraction takes place. In this, the velocity, ratio of velocity of light in vacuum to the velocity of light in the water. In the first case and third case, you see, two media are same. What is different? The angle at which the light strikes the surface. The surface, that term which we have to use is interface. Interface means the surface which separates two media. That is the interface. The angle at which the light ray strikes at the interface is different. Remaining thing is same. Because of this angle change, different in angle, here the deviation also different. The angle through which it is deviated from its original path also different, but the ratio of velocity of light in vacuum to the velocity of light in water, velocity of light in vacuum to velocity of light in water, that ratio remains constant. It is constant. If we take two media, same media, air, water, whatever be the angle at which the light strikes the interface, the ratio remains constant always till the media same. And that constant, the ratio of change in the ratio of velocity of light in vacuum to the velocity of light in any medium is always constant for the given pair of media. For the given pair of media. In the given direction, because the direction should not be reversed. In one case it is entering from air to water, in another case it is entering from water to air. Again the media same, angle same, but the direction reversed. In the given direction, and for the given pair of media, the ratio of velocity of light in vacuum to the velocity of light in any medium is always constant, and this constant is known as refractive index. Refractive index. This refractive index, when we study about the refractive index, in that we must know about the two media, because it is not the property of single medium. Here two media must be present. What light travels in which medium and enters in which medium, that we must consider. So that is refractive index of what? Refractive index of the medium into which it enters. So we say here it is entering into water, so we say it is refractive index of water. Because it is entering from air into water. And this refractive index is a quantity. It is a quantity which tells about how much velocity is changed when it enters from one medium into another medium. So this refractive index, it is given by the symbol mu. This is mu. Here C equal to nu lambda. This is nu frequency. This is mu, mu. Should say mu. So refractive index is equal to C upon V. Refractive index is the ratio of velocity of light in vacuum to the velocity of light in any medium. This is the basic formula for the refractive index. So here it is a ratio of same quantities. So refractive index has no unit. It has no unit. And further about this refractive index, we'll discuss in the next video.